So in this video we're going to look at the differentiator. So it's similar to the last video we looked at when we looked at the integrator. We've got here an inverting amplifier. So we've worked out previously that the V out is related to V in, and the inverting amplifier by minus Z2 upon Z1. So in this case our Z1 is a capacitor, and in the complex frequency domain it can be written as 1 upon SC, and Z2 is the resistant value R. So we can put these Z1 and Z2 into this equation. We get V out equals SCR times V in. So therefore we can, this is the complex frequency domain. So in the time domain that's equivalent to V out is equal to minus R times C, and multiplication by S in the complex frequency domain is equivalent to differentiation in the time domain. And the input here, Vi, is a function of time, so we are differentiating the input voltage with respect to time. So this here is our differentiator. Okay, now we built that in multisim as well, and you've got access to that and you can go and download it and have a wee play with it. Now our input here is going to be our triangular wave, so that's our input, and our output then is going to be a square wave. So we can see then how it's differentiating. The gradient here of this line is a fixed value, okay, so it's a fixed positive value, that's a fixed positive value there, and the gradient of this bit of line is a fixed negative value, so that's a fixed negative value there. But also we note that the differentiator, again, it's an inverting differentiator, okay, so the reality of it is if it wasn't non-inverting, this here would be in this direction, and this one here would be up in that direction. Okay, so that's all there is to this video. I'll get you on the next video. Okay, thank you, goodbye.